Why you're waiting? Let's go. Earth is dying, not in a dramatic Hollywood explosion kind of way, but slowly. The ice caps are shrinking, the oceans are warming, the air is getting harder to breathe, and every year, scientists add another decade to the timeline of when things start getting really uncomfortable for the 8 billion people living on this rock. But here's the thing most people don't know. While we've been arguing about how to save this planet, astronomers have been quietly building a list of worlds beyond our solar system where humans might actually be able to survive. Not in a spacesuit, not in a sealed bunker, on the surface, breathing, living. As of 2025, NASA has confirmed over 6,000 exoplanets, and a handful of them sit in the habitable zone of their star, the distance where liquid water could exist on its surface. Some of them are rocky like Earth, some of them might have atmospheres, and one of them, just 4 light years away, might have an ocean. Today, we're counting down the 10 most promising planets where humans could actually survive, and for each one, I'm going to give it a survival score: temperature, gravity, atmosphere, and water, each rated from 1 to 10. A perfect score is 40. Earth scores 36. Let's see how these alien worlds compare. Planet 10, Kepler 442b, the quiet overachiever. Let's start with a world that some scientists have argued might actually be more habitable than Earth. Kepler 442b orbits a cool orange dwarf star about 112 light-years away in the constellation Lyra. It was discovered in 2015 by NASA's Kepler Space Telescope, and it's been sitting near the top of habitability indexes ever since. The planet is about 1.3 times the size of Earth and receives about 70% of the sunlight we do. That might sound low, but it's actually a sweet spot. Too much sunlight and you get a runaway greenhouse effect like Venus. Too little and you freeze. Kepler 442b lands right in the middle, in the conservative habitable zone, meaning liquid water could exist on its surface under a wide range of atmospheric conditions. Its star is quieter than our sun. Orange dwarfs are more stable, with fewer solar flares, which means any atmosphere on Kepler 442b would have an easier time surviving. Some climate models suggest that with a modest carbon dioxide atmosphere, this world could maintain surface temperatures between 0 and 40 degrees Celsius, which is comfortable for human life. The catch? We know almost nothing about its atmosphere. It's too far away and too faint for the James Webb Space Telescope to analyze. We won't know what Kepler 442b is really like until the next generation of giant telescopes comes online. But based on what we do know, it's one of the most Earth-like worlds ever found. Survival score: temperature, 7, gravity, 6, atmosphere, 4, unknown, water, 5, likely, total 22 out of 40.
Planet 9, Kepler 452b, Earth's older cousin. When NASA announced the discovery of Kepler 452b in 2015, they called it Earth's older cousin, and the nickname stuck. This planet orbits a G-type star, the same class as our Sun, at almost exactly the same distance. Its year is 385 days long. It receives roughly the same amount of energy from its star as Earth does. But there's a twist. Kepler 452b's star is about 1.5 billion years older than the Sun. That means this planet has been bathing in habitable zone sunlight for 6 billion years, 1.5 billion years longer than Earth. If life ever started there, it had an extraordinary amount of time to evolve. The planet itself is about 60% larger than Earth, putting it in the super-Earth category. Its gravity would be roughly twice what we experience here, which means a person who weighs 70 kilograms on Earth would feel like they weigh 140 kilograms on Kepler 452b. You could still walk, you could still function, but everything would feel heavier, and your cardiovascular system would work harder with every step. At 1,400 light-years away, Kepler 452b is far beyond our reach with current technology, but it remains one of the most symbolically important exoplanet discoveries ever made because it proved that Earth-like conditions around Sun-like stars are not unique. They exist elsewhere, and they've existed for a very long time. Survival score: temperature 7, gravity 4, atmosphere 4, unknown, water 5, likely, total 20 out of 40. Planet 8, TOI 700d, the first Earth-sized world in the habitable zone found by TESS. In January 2020, NASA announced a landmark discovery. The Transiting Exoplanet Survey Satellite, known as TESS, had found its first Earth-sized planet in the habitable zone of its star. The planet is TOI 700d, orbiting a small, cool red dwarf star about 100 light-years away in the constellation Dorado. TOI 700d is almost exactly the same size as Earth and orbits in the optimistic habitable zone. It receives about 86% of the energy that Earth gets from the Sun. Climate models suggest that if the planet has an ocean and a carbon dioxide-rich atmosphere, surface temperatures could support liquid water. The host star, TOI 700, is unusually quiet for a red dwarf. Most red dwarfs blast their planets with violent flares that can strip away atmospheres. But TOI 700 shows very little flare activity, which significantly increases the chances that TOI 700d has retained its atmosphere over billions of years. In 2023, TESS discovered a fourth planet in the system, TOI 700e, which also sits in the habitable zone. Having two potentially habitable worlds in the same system is exceptionally rare and makes this star a priority target for James Webb Space Telescope follow-up observations. Survival score: temperature 7, gravity 7, atmosphere 5, stable star, water 5, modeled. Total 24 out of 40.
Planet 7, LHS 1140b, the super-Earth with water vapor clues. About 40 light-years away in the constellation Cetus, there's a planet that might look like a giant eyeball from space. LHS 1140b is a super-Earth roughly 1.7 times the diameter of our planet and about 5.6 times its mass. It orbits a red dwarf star every 25 days, and it's almost certainly tidally locked, meaning one side always faces its star while the other remains in permanent darkness. If the planet has an atmosphere, the day side would be warm and sunlit, potentially hosting a circular ocean surrounded by ice. From above, it would look like a massive eye staring out into space. This is why scientists sometimes call these worlds eyeball planets. In 2024, data from the James Webb Space Telescope provided the first hints that LHS 1140b might have an atmosphere containing water vapor. The signals were tentative but exciting because LHS 1140b sits squarely in its star's habitable zone. If water vapor is confirmed, it would be the strongest evidence yet that a rocky super-Earth can maintain an atmosphere with the ingredients for life. The gravity on LHS 1140b would be about 3 times Earth's surface gravity if it's purely rocky. That's intense. A person weighing 70 kilograms would feel like 210 kilograms. Standing would be exhausting. But if the planet has a thick atmosphere, the increased air pressure might partially compensate for the gravitational challenge, and certain organisms, especially aquatic ones, would handle it much better than land-based creatures. Survival score: temperature 6, gravity 3, atmosphere 6, JWST hints, water 7, vapor detected, total 22 out of 40. Planet 6, GJ251c, the super-Earth next door. In October 2025, a team led by the University of California, Irvine announced a discovery that immediately shot to the top of habitability priority lists. GJ251c is a super-Earth about 4 times the mass of our planet, orbiting smack in the middle of its star's habitable zone, and it's only 18 light-years away. The planet orbits a red dwarf star called Gliese 251, completing 1 year every 54 days. Suvrath Mahadevan, professor of astronomy at Penn State University, said the planet sits in the Goldilocks zone at the right distance from its star where liquid water could exist on its surface, if it has the right atmosphere. What makes GJ251c particularly exciting is its proximity. At 18 light-years, it's close enough for the upcoming 30-meter telescope to potentially image it directly. The discovery required 20 years of observations and data from multiple instruments, including the Habitable Zone Planet Finder at the McDonald Observatory in Texas and the NEID spectrometer at Kitt Peak in Arizona. Climate simulations by the team suggest that if GJ251c has a carbon dioxide-rich atmosphere similar to Venus or early Mars, surface temperatures could be remarkably Earth-like. However, if the planet has an atmosphere identical to Earth's, it would actually be too cold, because the star's lower energy output wouldn't provide enough warmth. This means the planet needs a thicker greenhouse blanket than Earth has. The question is whether that atmosphere exists, and only the next generation of telescopes can answer it. Survival score: temperature 6, gravity 4, atmosphere 5, modeled, water 5, possible, total 20 out of 40. Planet 5, TRAPPIST-1e, the best bet for an atmosphere on a rocky world. If any single exoplanet is going to rewrite the textbooks in the next 12 months, it might be TRAPPIST-1e. This Earth-sized world orbits within the habitable zone of TRAPPIST-1, an ultra-cool red dwarf star just 39 light-years away. It's one of 7 Earth-sized planets in this extraordinary system, all packed so tightly that they would fit inside Mercury's orbit around our sun.
In September 2025, two separate teams using the James Webb Space Telescope published what they called tantalizing hints of an atmosphere on TRAPPIST-1e. Ryan McDonald at the University of St. Andrews in Scotland, co-author on the papers, said they were seeing something that could be huge. If confirmed, it would be the first atmosphere ever detected on a habitable zone rocky planet beyond our solar system. The data showed possible signs of methane, but the signal is complicated by the star itself. TRAPPIST-1 is a tiny, volatile red dwarf star that frequently erupts with flares, and those flares can mimic atmospheric signatures in the data. Separating the planet's signal from the star's noise is one of the most difficult challenges in exoplanet science today. A follow-up campaign is already underway, observing 15 more transits of the planet. Nestor Espinosa at Johns Hopkins University, who leads the campaign, said the results should be published in 2026. Those results could be the most important exoplanet data ever released. If TRAPPIST-1e has an atmosphere, it means red dwarfs, the most common stars in the galaxy, can support habitable worlds, and that would multiply the number of potentially life-bearing planets in the Milky Way by orders of magnitude. The gravity on TRAPPIST-1e is roughly 93% of Earth's, which means it would feel almost exactly like home. Walking, running, breathing, everything would feel natural. And if that atmosphere exists and holds water, this might be the most human-compatible alien world we've ever identified. Survival score: temperature, 7, gravity, 9, atmosphere, 7, strong hints, water, 6, possible, total, 29 out of 40. If you're mentally packing your bags for TRAPPIST-1e right now, hit the like button before you go. It tells the algorithm this content matters, and it means more people get to learn about these incredible worlds. Now let's keep going, because the top 4 planets are even more promising. Planet 4, Proxima Centauri b, the closest habitable world to Earth. This is the planet that changed everything. In August 2016, astronomers announced the discovery of an Earth-sized world orbiting in the habitable zone of Proxima Centauri, the closest star to our solar system at just 4.2 light-years away. It was the moment exoplanet science went from theoretical to tangible. There is a potentially habitable planet right next door. Proxima b has a minimum mass of about 1.3 times Earth's. It orbits its star every 11.2 days and receives about 70% of the energy that Earth receives from the sun. Under the right atmospheric conditions, liquid water could exist on its surface. But there's a serious problem. Proxima is a red dwarf, and unlike the quiet star of TOI 700, this one is violent. In 2019, astronomers recorded a superflare from Proxima Centauri that was 100 times more powerful than any solar flare ever observed from our sun. These flares blast the planet with extreme ultraviolet radiation that could strip away its atmosphere and sterilize the surface. So how could anything survive? Some models suggest that if Proxima b has a strong magnetic field, like Earth's does, it could deflect most of the stellar radiation. A thicker atmosphere with a layer of ozone or water vapor could absorb much of the rest. And if the planet is tidally locked, any life could potentially shelter on the night side or in a twilight zone between the day and night hemispheres. In August 2025, JWST found strong evidence for a Saturn-mass gas giant orbiting Alpha Centauri A, the nearby Sun-like star that's part of the same triple star system as Proxima Centauri. If a gas giant exists in that system, it's possible that moons orbiting that planet could also be habitable. The Alpha Centauri system, our closest stellar neighbor, is turning out to be far more complex and far more interesting than anyone expected. Survival score: temperature, 6, gravity, 8, atmosphere, 5, uncertain, water, 5, possible, total, 24 out of 40.
Planet 3, K2-18b, the planet with possible signs of life. This planet has generated more scientific controversy in 2025 than any other world in the galaxy. K2-18b is a sub-Neptune, about 8.6 times the mass and 2.6 times the radius of Earth. It orbits in the habitable zone of a cool red dwarf star 124 light-years away in the constellation Leo. In April 2025, a team led by Niku Madhusudan at the University of Cambridge published what they called the strongest evidence yet of potential biological activity beyond our solar system. Using new transit spectra from the James Webb Space Telescope, the researchers detected the chemical fingerprints of dimethyl sulfide, or DMS, and possibly dimethyl disulfide in the planet's atmosphere.
These are the first carbon-based molecules ever identified in the atmosphere of a habitable zone exoplanet. On Earth, DMS is produced almost exclusively by marine microorganisms, phytoplankton in the ocean. It's the gas that gives the sea its distinctive smell. Finding it in the atmosphere of an alien world is, to put it mildly, provocative. But the scientific community pushed back hard. Critics argued that the JWST signal was too noisy and too weak to draw definitive conclusions. The debate drew attention to the limits of JWST, which was designed before sub-Neptunes like K2-18b were even known to exist. Madhusudhan estimated that an additional 16 to 24 hours of JWST observation time would be needed to reach the statistical threshold required for confirmation. K2-18b is not a rocky planet like Earth. It's likely a Hycean world, a planet with a thick hydrogen-rich atmosphere over a global ocean. The surface pressure could be crushing, and the atmosphere might contain hydrogen in concentrations toxic to human life. You couldn't walk on this planet. But microbial life in its ocean? That's a different story entirely. If DMS is confirmed, K2-18b becomes the most important planet ever discovered outside our solar system. Not because humans could live there, but because something else already might. Survival score. Temperature, 7. Gravity, 2. Atmosphere, 8. DMS detected. Water, 9. Likely ocean world. Total, 26 out of 40. Planet 2. TRAPPIST-1F, the cold sibling with hidden potential. Everyone talks about TRAPPIST-1e, but its slightly cooler sibling, TRAPPIST-1F, might deserve just as much attention. This planet orbits a bit farther from the star, at the outer edge of the habitable zone, receiving about 40% of the energy Earth gets from the Sun. That puts it in a position similar to Mars in our solar system, except TRAPPIST-1F is larger and denser. TRAPPIST-1F is about 1.45 times Earth's mass, and its radius is only 4% larger than Earth's. That means its surface gravity is strikingly close to ours. You would weigh almost the same there as you do here. The planet is likely tidally locked, and at the outer habitable zone edge, its day side might have temperatures in the range of 0 to negative 20 degrees Celsius with the right atmospheric greenhouse warming. Cold, but survivable. Think Antarctica with slightly thicker air. Why does TRAPPIST-1F matter? Because sometimes the best places for life aren't the warmest. On Earth, some of the most resilient organisms live in the coldest environments. Extremophiles thrive in deep Antarctic ice, in deep ocean hydrothermal vents, and in permafrost. If TRAPPIST-1F has an atmosphere and subsurface liquid water kept warm by tidal heating from its neighboring planets, it could be a sleeper candidate for habitability. JWST is currently observing TRAPPIST-1F, along with 1G and 1H for signs of an atmosphere. Results are expected in 2026. If multiple planets in this system have atmospheres, it would be the most significant discovery in the history of astrobiology, an entire system of potentially habitable worlds just 39 light-years away. Survival score. Temperature, 5. Gravity, 9. Atmosphere, 5. JWST watching. Water, 6. Subsurface possible. Total, 25 out of 40. Planet 1. TRAPPIST-1e, the frontrunner, returns. There's a reason TRAPPIST-1e appeared at number 5 for its scientific breakthroughs and now returns at number 1 for sheer survival potential. When you combine every factor that matters for human survival, no exoplanet currently known scores higher. Let's run through the numbers one more time. Size, 1.01 Earth radii, almost identical. Mass, 0.69 Earths, lighter than Earth, meaning the gravity is about 93% of what you experience right now. Surface gravity that feels like home. Distance from star, right in the center of the habitable zone, not at the inner edge where a runaway greenhouse is a risk, not at the outer edge where freezing is a concern. Dead center. Star type? Yes, it's a red dwarf, and red dwarfs are problematic, but TRAPPIST-1e sits at a distance where atmospheric models suggest a moderate greenhouse effect could maintain surface temperatures between 0 and 30 degrees Celsius, with liquid water, clouds, and weather patterns that might look eerily familiar. And the September 2025 JWST data showing hints of an atmosphere? If confirmed in 2026, TRAPPIST-1e becomes the only known rocky exoplanet in the habitable zone with a confirmed atmosphere. That alone makes it the single most important target in the search for life and the search for a second home. Imagine standing on the surface of TRAPPIST-1e. The sky is a deep salmon pink because of the red dwarf light. The star itself looks enormous, spanning several times larger than the Sun appears from Earth because you're orbiting so much closer. 6 other planets are visible in the sky, some appearing larger than the Moon does from Earth. A sunset here would last longer because of the star's cooler, redder light. And on a clear day, looking up, you would see worlds. We are 39 light-years away. With current chemical propulsion technology, that's about 700,000 years of travel time. But with next-generation propulsion concepts like solar sails accelerated by laser arrays, that could drop to decades. The Breakthrough Starshot initiative, funded by the same people behind Breakthrough Listen, aims to send gram-scale probes to nearby star systems at 20% the speed of light. At that velocity, TRAPPIST-1e is within reach in under 200 years. TRAPPIST-1e is not science fiction. It's a real world. It exists right now, and in 2026, we might finally know if it can breathe. Survival score: temperature, 8. Gravity, 9. Atmosphere, 7. JWST hints and 2026 confirmation pending. Water, 7. Modeled, likely. Total, 31 out of 40. If this countdown made you rethink what's possible beyond Earth, subscribe and hit the notification bell. Don't forget to like this video, and tell me in the comments if you could visit any of these 10 worlds, which one would you choose? The quiet overachiever Kepler 442b, the biosignature mystery of K218b, or the closest thing to home we've ever found, TRAPPIST-1e. See you in the next one.